The day starts on the parking lot. The F-35 is undercover. A shift of technicians is working around. Documents are checked. Tasks are assigned. Tools and safety equipment are laid out. The suspension area is marked. Cones and signs are set up. A ground power source and nitrogen cart are all ready at the side. Preparations for weapons and takeoffs begin. Carts with ammunition leave the weapons depot. The first one carries AIM-120 missiles. The second one a set of guided bombs. The accompanying vehicle carries pyrotechnic blocks, fuses, and a set of cables. Each unit is sealed. 2 people check the list. A third keeps a log. There are no unnecessary movements. Everything goes according to the map. The plane is connected to ground power. The cockpit is open. Red remove before flight tapes are visible on board. The pilot is undergoing an external inspection, touching panel locks, looking at sensors, checking tire numbers and pressures. In the landing gear bays, an inspector is checking hydraulic lines and the door drive, and nearby an electronics technician is running unit checks. The internal weapon compartments are opened. The suspension mechanism strut is adjusted. Guides and stops are installed on the lower beam. The lock travel is checked. The contact pads are lubricated. The connectors are cleaned. The task is simple and straightforward, to ensure that nothing touches when closing the doors and that nothing gets stuck when dropping them. A cart with an AIM-120 is brought to the site. The gunsmiths take the load by weight and lift it with a jack. Align the end of the guide with the lock, check the fit using the marks, insert the cotter pins, secure the latches. The torque wrench is set to the standard. The clamp is tightened evenly. The second number announces the tightening torque and makes a mark with a marker. Next comes a set of bombs. A platform elevator approaches the compartment hatch. The operator lifts the product to the required height. The power units are connected. A safety chain is installed. The casings are closed. The interface cable is connected. A confirmation message appears on the panel in the cabin. A short test is carried out. A green signal means that the data exchange is proceeding without errors. The electronics cooling system is checked. The filters in the sensor fairings are changed. The air ducts are blown out. The fuel is monitored at the same time. A sample is taken. Moisture and impurities are checked. The tank temperature is recorded. If necessary, it is refilled before the flight mission, and the hose from the docking port is put away in a cover. The pilot's helmet is loaded with customized settings. The visor is aligned. The image alignment with the aircraft's axis is checked. The display and backlight test is turned on. The helmet fits tightly. There is no play in movement. The headset communication is clear and noise-free. And at the briefing, the pilot confirms the route, flight levels, and work points. The moment for launch arrives. The technical staff removes the blocks and tools, leaving only the chocks. The cabin is closed. The power is switched to the onboard power supply. The engine is revved up to idle. The temperature sensors enter the working area. A short command from the launch site is broadcast, and the green corridor opens on the taxiway. The F-35 starts moving, checks the control surfaces, performs a braking check, enters the executive mode on command. The required mode is engaged. Fuel consumption and temperature are controlled automatically. The runway is clear. There is a slight headwind. There are no course deviations. The crew is ready for takeoff. The takeoff roll is smooth and without jerks. The afterburner picks up. The nose rises. The landing gear retracts into its bays. The doors close. The plane begins to climb. Short confirmations from the controller and wingman are heard in the headphones. The route is based on the mission computer's navigation. All flight parameters are synchronized. In the air, the pilot checks the operation of the radar and optical electronic system, opens the tactical screen, practices the acquisition of training targets. The interaction model with wingmen is practiced without unnecessary remarks. Each command is short and clear. The system itself suggests options. The human confirms and monitors. A visual inspection is performed over the runway, followed by a vertical climb. The automation smooths out oscillations. The angles stabilize. The flaps are visible. The aircraft maintains its control mode confidently. And at altitude, a repeat weapons test is conducted, simulating suspension of different profiles, checking the exchange with each strut and the response to commands. Meanwhile, on the ground, the second shift prepares the next flight. The rocket carts move in a column. The transport stops are removed just before installation. The surface is inspected for chips and scratches. All defects are recorded. Faulty components are taken away for repair, and the working ones are immediately marked and placed under the aircraft. The gunsmith's work isn't noisy, but it demands precision. 3 pairs of hands, 1 team, each responsible for their own step. Alignment of guides, fixation, cable, testing, signature in the logbook. If even one element doesn't meet the parameters, the suspension is removed and they start over, because in the air there's no time for adjustments. A separate block is dedicated to brake and tire maintenance. They remove the caps, measure the remaining tread, check the pressure, look at the temperature after the previous flight, and if there are signs of overheating, open the air vents and take a break. All the data is sent to an electronic report, which is available to the engineer and flight commander. The first aircraft returns, runs down the runway, touches down softly, reverse thrust is applied. The plane turns onto the taxiway, releases the brake parachute. If this is stipulated by the training scenario, the replacement crew is already running up to the parking lot. They put on the chocks, connect the power, the canopy opens, the pilot stands up, reports on the health of the systems. The post-flight inspection begins, examining edges and panels, looking for signs of heating, checking antenna mounts, capturing video and sensor data, and a full report is filed. If vibrations or deviations were observed during the flight, the maintenance crew immediately schedules an additional inspection of the unit to avoid prolonging the downtime. If the aircraft has been flying with a sling, the used parts or simulators are removed, the mock-ups are unloaded, the compartments are closed, the contact pads are washed, dried, and hidden in covers. At the same time, the engine is serviced, panels are removed, the blades are checked, play and impact marks are examined, and an endoscope is used to detect minor defects. A dusk takeoff is scheduled for this evening, meaning the lighting and thermal sensors are retested. The crew receives a new mission card. Warning lights are turned on along the apron. The takeoff team checks the runway for clearance, and additional observers are deployed to the designated spots to secure the taxiways. Footage of a night start is always spectacular, but behind the scenes are the numbers: exhaust temperature, RPM oil pressure, currents on the post-launch lines. Each value is normal, but if even one goes out of range, the takeoff is cancelled. This is how safety control is set up, where there is no room for compromise. The plane heads off into the darkness, with only a line of lights and the afterburner jet glowing at the far end of the runway. A few short phrases are broadcast. The controller gives the corridor, the wingmen take up their sectors, and on the ground, the shift clears the apron and returns the instruments to their slots so that by morning, everything will be in its place. By morning, the conveyor is revving up again. The aircraft undergoes medium-scale maintenance. They remove the panels around the air intake, clean the drains, renew the heat-conducting paste at the contact points of the blocks, check the battery and charge it to the calculated level, run the backup generator on the stand, and simultaneously test the emergency power supply for the catapult systems. Another step is updating the mission software package. The software engineer connects the secure drive, verifies checksums, transfers the communication profile, frequency tables, and onboard keys. Upon completion, he makes a control entry in the log and generates a report. Without this, the aircraft will not be sent on a mission because navigation and communication are half the battle. We return to the armament procedures, this time training for accelerated suspension. All actions are carried out within a tight time frame. The hands on the scoreboard are ticking, but the quality remains high. To speed things up, they use pre-prepared carts and laid out tools. At the signal, they stop the clock and check the checklist.